72 billion events every single day. Monday morning, 8 a.m., São Paulo. You are heading to the subway, it's packed, as always. Everyone around you has their phone out, checking a balance, paying for a coffee, sending money to a friend. Now multiply that by 122 million customers spread across Brazil, Mexico, and Colombia. And if anything goes wrong, even just a slow connection, you are already furious. This is NuBank, one of the largest digital banks in the world. And in this video, I'm going to show you how it actually works under the hood. Not the theory, the real engineer decision they documented publicly. NuBank started in 2013. One product, one credit card, a small team, a few thousand lines of code. Fast forward to 2025, and the numbers are from a different world. Over 122 million active customers, 4,000 microservices running simultaneously, 72 billion events processed every single day, 1,600 terabytes of log ingested daily. And here's the thing most people don't say out loud. The architecture that handles 1 million users will collapse at 10 million. The one that handles 10 million will collapse at 100 million. NuBank had to reinvent its own infrastructure multiple times. And the decisions that looked most controversial at the beginning were exactly what made this scale possible. In 2013, when everyone was building with Java, Python or Ruby, NuBank chose Clojure, a functional language running on JVM, considered academic. Almost nobody uses it in production. But NuBank CTO saw something others didn't: immutability. Imagine two processes trying to update an account balance at the same time. With mutable date, race condition, bugs that appears out of nowhere. With immutable date, each transaction creates a new version of this state. You never overwrite, you only append. And that same philosophy leads to the second big decision, the database. NuBank doesn't use Postgres for its core, it uses Datomic. Think of it like Git, but for database. In traditional Postgres, when you update a record, the old value is gone. In Datomic, every change is a new fact added to the timeline. The complete history is preserved forever. If a customer calls to dispute a charge from 6 months ago, NuBank can see exactly what the system looked like at the exact moment. Not a backup, the actual real state, navigable through time. NuBank believed in Datomic so much that in 2020 they acquired the company that built it. If Datomic is the brain, Kafka is the nervous system. 72 billion events per day flow through Kafka at NuBank. When customer open the app, when check their balance, when transaction approved, when payment processed. Instead of storing just the current state, they stored every event that led to it. Think of your bank statement. You don't just see a final balance of 100,000. You see every deposit, every withdrawal, every transfer. The balance is the result of applying all those events in sequence. Kafka acts as an immutable distributed log. Messages stay available for days or even weeks. Each service consumes at its own pace, independently. The services that approve a transaction has no idea push notification services even exist. Both consumes from the same Kafka topic. Completely independently, in 2016, NuBank ran in a problem very few companies ever face. AWS ran out of machines to keep up with NuBank's growth rate. The obvious fix? Database sharding. Split the data across multiple databases. Problem solved. But what if the bottleneck isn't the database at all? What if it's Kafka, batch processing, the network layer? NuBank's solutions was far more radical. They cloned the entire infrastructure. Each NuBank shard isn't just a database partition, it's a full copy of everything. All microservices, dedicated Kafka cluster and topics. Separate Datomic instance, completely isolated networks. Today in Brazil, NuBank runs 20 shards. When you log in, the system knows exactly which shard you belong to and routes everything there. If one shard goes down, only a fraction of customers are affected. New features can be tested on a single shard before rolling out to everyone. Fault isolation and safe deploys, baked directly into the architecture. When you tape your NuBank card at any terminal, a race begins. Terminal to acquire to MasterCard or Visa, network to NuBank, NuBank responds. Approve it or decline it in under 100 milliseconds. Take any longer and the transaction fails. No second chance. NuBank's engineering team recently cut critical path latency from 1000 milliseconds down to 288 at P19. A 76% reduction on the most critical path in the entire system. How? By removing synchronous dependency from the critical path. Instead of fetching data in real time, they pre-computed and materialize what's needed. The heavy computation happens at write time, not read time. Now, with 400 microservices, how do you even know what's happening inside NuBank? At some point, the cost of their external logging solution got so high, they could have hired Lioness Messi as a software engineer for the same price. So NuBank built their own platform. They call it Alexandria. Result? 50% cheaper than the external solution, full control over their data, and 95% compression on storage. So what actually makes NuBank work at this scale? Deliberate decisions. Clojure and immutability. Eliminate entire categories of bugs in concurrent system. Datomic. Time as first-class citizen. Completed, auditable, navigable history. Kafka and event source. 72 billion events per day, fully decoupled. Scalability units. Don't shard the database. Clone the entire infrastructure. Read optimizer writes. Pre-compute at write time. Serve reads in milliseconds. In-house observability. When the bills reach messy level, you built it yourself. NuBank didn't scale by accident. They scaled through deliberate decision, some of them looking very risky at the time. If you got out of this, hit the like button. It genuinely helps the channel. And tell me in the comments, which architecture do you want to see next?